Well, we're going to continue our discussion of the big 5 traits today. And I'm going to talk to you about openness and intelligence, roughly speaking. So the first thing I want to do is put them into context. You need to understand where intelligence fits in the trait hierarchy structure. And so we've looked at this before, but you can break the big 5 into the big 2. Plasticity and stability. We'll start with stability here. And stable people are conscientious, high in stress tolerance or emotional stability, or low in neuroticism, depending on how you look at it, and high in agreeableness. And then conscientiousness breaks down into industriousness and orderliness. Neuroticism breaks down into volatility and withdrawal, and agreeableness breaks down into politeness and compassion. And then for the second major trait, you have the big 2 trait, you have plasticity, and plasticity is made up of extroversion and openness, and those look like, the reason they clump together, the reason the first 3 clump together, we think, is because they're roughly associated with serotonergic function, and the reason the latter 2 clump together is because they're roughly associated with dopaminergic function, and the dopamine system mediates exploratory behavior in the face of the unknown, but it also mediates positive emotion. And it's because in order to move forward into the unknown, it isn't that you have to experience positive emotion, it's that the emotion you experience when you're motivated to move forward into the unknown and explore is a positive emotion. And positive emotion is very much also associated with interaction in the social environment. And maybe that's because a tremendous amount of what you're doing in the social environment is essentially exploratory behavior, right? Because, for example, when you're communicating with people, that's primarily exploratory behavior. So it's not surprising that the circuitry overlaps in that manner. Openness is the one we're going to concentrate on most particularly today. And it's openness to experience technically, and it seems to break down into intellect and openness proper, which is, it's intellect, which is interest in ideas, maybe facility with ideas, and openness, which is more like creativity. That's now, you can't divide them into interest in ideas and creativity so precisely because they overlap to a great degree. But there is reason for differentiating between them. So for example, women are about 1/3 of a standard deviation higher than men in openness/creativity, and men are about 1/3 of a standard deviation higher than women in interest in ideas and intellect. And that's actually quite a substantial difference within a trait that's, when the 2 traits are so highly correlated. So there's reason to do the fractionation. So anyways, so we're going to concentrate on openness today, and the reason that I'm presenting the trait description first rather than moving immediately into, say, IQ and creativity is because it's useful to know that you can take intelligence and put it in the big 5 taxonomy. And you can actually measure intelligence a lot more accurately with an IQ test, and perhaps also with a creativity test, than you can with a self-report personality test that relies on adjectives, you know, because I could ask you guys, well, how smart are you on a scale of 1 to 7? And that would be roughly correlated with your IQ. But if I really wanted to know how smart you were, roughly speaking, it would be much better to give you an IQ test. And if I was wanting to know how creative you are, rather than asking you how creative you are and getting you to report, even though there would be some accuracy in that, it would be better actually to give you some of the different tests of creativity that we'll talk about today. Now, the weird thing about the big 5, or one of the weird things about it, is that we don't have great tests for the traits independently of self-report for almost all of the traits. So for example, one of the things that I've been trying to do in my lab for the last 5 years is to find some sort of laboratory task that conscientious people do better on or unconscientious people do worse on. And you'd think that would be simple because conscientiousness, for example, is a very good predictor of long-term life success. It's also a very good predictor of university grades. It's not as good as IQ, but it's still a good predictor. But we have had one insanely difficult time trying to find a non-self-report test that actually predicts conscientiousness. So, much appreciated. Yes.
Could it be that being conscientious has something to do with like being more self-aware? It's hard to test for being self-aware.
No, it's neuroticism. Neuroticism is associated with being more self-aware. And it's actually, it loads on negative emotion. So being self-conscious is associated with being high in negative emotion. I mean, you can assess neuroticism using tests that ask you about anxiety and emotional pain or depression, but that's also not much different than self-report. Anyways, we're going to concentrate on openness today. And we're going to concentrate both on creativity and intelligence. And there's actually almost nothing in psychology that's more contentious, generally speaking, than the investigations into the technical or the set of skills and abilities that falls under trait openness. And the reason for that, and this is especially the case with intelligence, is that intelligence is actually quite measurable. We've been able to measure it since roughly the beginning of the 20th century. Binet originated the first, I would say, reliable and valid IQ tests, and they've been used quite extensively for a long period of time. And IQ, I'll tell you what IQ is as we go through this, but there isn't anything that social scientists have been able to measure more successfully than IQ. And there's nothing that or very little. There's one exception. The relationship between income inequality and male homicide is a more powerful relationship than the relationship between IQ, say, and general life success, or IQ and general school success. It's even a little stronger than the relationship between IQ and the rate at which you learn something new. But other than that, it's pretty slim pickings. And so we're going to walk through very carefully how IQ tests are created and formulated, and exactly what it is that they measure and why. And we'll equate that to some degree to creativity, and also differentiate it from creativity as well, making the assumption that the aspects of openness, intellect and openness proper, are the proper aspects, and that they're usefully differentiated. So the first thing that you might want to consider is that the world is a very complicated place. Now, we've talked about this before. And the way that you handle, there's way too much complexity for you to handle in its entirety. So for example, in a room like this, there's an endless number of phenomena that you could focus your attention on, right? From the sort of macro phenomena, which would be the overall, say, color or appearance of the room, to the micro phenomena, which would be the details at the highest level of detail that you're able to perceive that litter the landscape anywhere. And so one of the problems that you have to solve when you're operating in the world is how you perceive the world. And we do that in part by making, I would say, that we perceive low resolution representations of the world, and we also confuse those with the world. So when I'm looking at you, I'm really looking at what I perceive consciously is a low resolution representation of you, right? I only see the front of you to begin with. I only see your surface. And in some sense, I even perceive you in some sense as a more or less uniform color. It's hard to tell exactly what color skin is. It's sort of a light pink, roughly speaking. But my perception is fairly, I don't know a better way of putting it than low resolution. And I seem to perceive you at the level of resolution that's sufficient, the lowest resolution that's sufficient to facilitate our interactions, because I don't want to clutter up my perceptions of you when we're just talking with excess detail. So there's lots of things about you I don't need to see. I certainly can't see any of your microstructures below the phenomenal level. Like, I can't tell without tremendous further investigation what you're made of biologically, for example. And I certainly can't perceive the networks of society that you're engaged in, your family or the other sorts of networks that you're embedded in. I see you here now, the front of you, at low resolution. And you can tell that to some degree, and we've talked about this before, because if you see, say, animated movies that use very low resolution representations of people, like South Park's a really good example, because the animation in South Park's very iconic and simple. It actually makes almost no difference to following the story. And so that shows you how iconic your perception really is. It can be replaced by very simple icons, and you instantly adapt to that. And so we can go and see the Lego movie, Batman Lego movie, for example, and the fact that it's Batman, which is an abstraction to begin with, and then it's made out of Legos, is almost irrelevant to following the plot. And so some people have compared our perceptions to the user interface on a computer. You know, when you're interacting with your computer, you don't really interact, so to speak, with the computer. There are iconic representations on the screen of the computer that you interact with, and those represent, obviously, they share some functional relationship with what's going on in the computer, but mostly they're there so that you, using your perceptual structures, can interact with the computer in a manner that's easy for extremely intelligent apes, roughly speaking. Now, so one of the problems that you have to solve in the world, because it's so full of detail and so complex, is how do you actually see the world? How do you actually perceive it? And it isn't really self-evident that that's a problem, because you think when you look at the world that it just presents itself to you. But it's a tremendously complicated problem, and that's partly why developing artificial intelligence systems that can actually see the world and act in it in any real way has proved to be a much more difficult problem than people had originally supposed. Because, you know, we were told maybe from the early 60s onwards that such things as speech to text or object recognition or robots that could operate in the world were only 2 or 3 years away. And well, I mean, we're in a situation now where there are some fairly complicated robots built, but they're still really in their nascent form. And it's because perceiving the world and then figuring out how to act in it turns out to be a much more complicated problem than we originally thought, because the borders between things are not self-evident. And what level of resolution you should be perceiving things at for, say, maximal functional utility is also not self-evident. It's also tied up very strangely and in ways we don't understand with the nature of your embodiment, you know. So, for example, we tend to see things that are handy because we can pick them up and manipulate them, and we can make use of them. And so to some degree, our brains are evolved to make the world manifest itself to us in a set of discrete usable tools. That's a reasonable way of thinking about it. And they're discrete and usable because we have a certain kind of biological platform, you know, because we have hands and mouths, and because we walk in a bipedal manner, then it's logical for us to break up the world in a manner that makes operating in this body maximally useful. But that doesn't mean that there's a straightforward one-to-one relationship between our perceptions of things and the things themselves. Quite the contrary. And that's partly, of course, we know that because with any perceptible object, like I could conceptualize you as one thing for all sorts of purposes, but if I'm trying to solve a complex problem in relationship to you, it's going to be very difficult to determine how to conceptualize you. So if you come to me because you're suffering from a psychological problem of some sort, then I have to figure out, you know, is it organic? Is it there's actually something physiological wrong with you? And I need to know what level of analysis I would probably conceptualize you at. Is it psychological? And if it's psychological, is it functional? Like, do you lack the skills, or do you lack the ability to apply the skills? Or is there something really gone wrong with your family? Or maybe it's even a reflection of an overarching sociological problem. We know, for example, that when the unemployment rate goes up 1%, psychiatric hospitalizations go up 5%. And so then you might ask, well, you know, if there's a huge rise in depression and anxiety across the population, and at the same time there's a huge increase in unemployment, you have to ask yourself what level of perception would best be suited to solve that problem, because it isn't self-evident that it's psychological at the level of the individual. Anyways, my point is that perception is a very difficult problem. And so now here's something interesting. You can think about this for a minute. I went and saw an autistic woman speak at one point. Her name was Temple Grandin. She's really worth looking up. Temple Grandin is a very interesting person. She's very seriously autistic when she was a child, but her mother and her worked her out of it so that she's very functional. She works as a professor. I don't remember where. It's in the Midwest somewhere. Now, she's famous not only for being a highly functional autistic person who talks a fair bit about what it's like to be autistic, but also for designing slaughterhouses across the United States. And the reason she can do that, as far as she's concerned, is because she thinks like an animal thinks. And so she doesn't, and she's identified maybe at least part of what the core problem is with autism. So the talk I heard her at was in Arizona, and it was a really an entrancing talk. She showed some really interesting pictures of animals. So what she's done is she's redesigned slaughterhouses so that when the animals enter the slaughterhouse, they go in like a spiral, basically. They can't see what's around the corner, and the walls are high, so they're not distracted by anything outside. So one of the things she showed, for example, was a bunch of cows going through a standard sequence of gates, essentially. And off to the side, there was a windmill spinning, and the cows would stop because the windmill, they didn't understand what the windmill was, and they'd stop. Or showed other pictures where cows were going down a pathway too, and there was a Coke can sitting in the middle of the pathway, and the cows would all stop because they didn't know what to do with it. Or she had another picture of cows out in the middle of the field, all surrounding a briefcase, and they were all looking at the briefcase. And the cows didn't like anything that shouldn't be there and had a hard time mapping it. Now she said, here's a little exercise she did. She said, think of a church. Okay, so maybe you imagine a child's drawing of a church. It's like your standard house, like a pentagon, right? Which is basically how children draw the front of a house, with a steeple on top and maybe a cross on top of it or something like that, which actually isn't at church. It's an icon of a church. And you think about how children draw houses too. Pentagon, rectangle, what is it, trapezoid, chimney, almost always with smoke, which is quite interesting. I don't know where kids get that exactly, but they almost always draw a chimney with smoke, even though chimneys with smoke aren't that common anymore. But anyways, you can see what a child's picture of a house looks like in your imagination. One of the things that you might want to think about is that is not a picture of a house at all, right? It's an iconic representation that's kind of like a hieroglyph, because no house looks like that. And then you think about how a child will draw a person. Circle, stick, 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 stick. And you show it to someone and they go, that's a person. It's like, really? It looks nothing like a person, right? You immediately recognize it as a person, but it looks nothing like a person. Well, what Grandin said was that when she thinks of a church, she has to think of a church she's seen. She can't take the set of all churches and abstract out an iconic representation and use that to represent the set of all churches. She gets fixated on a specific exemplar. And she thinks that one of the problems with autistic people, and they have a very difficult time developing language, by the way, is that they can't abstract out a generalized representation across a set of entities. They can't abstract. And of course, if you can't abstract, then it's also very difficult to manipulate the abstractions. And you see very strange behavior with autistic children, for example. So they don't like people. And that's because people don't stay in their perceptual boxes. Like a human being is a very difficult thing to perceive because we're always shifting around and moving and doing different things. Like we don't stay in our categorical box. So autistic people have real trouble with other people. But they also have trouble. So for example, if your autistic child gets accustomed to your kitchen, let's say, and you move a chair, then especially if they're severely autistic, they'll have an absolute fit about it. Because you think kitchen with chair moved. They think completely different place. Because they can't abstract the constancies across the different situations and represent them abstractly. So I made this little diagram. I made this little diagram here to kind of give you a sense of what you might be doing when you're abstracting perceptually. And so you could say, think about something that's that complicated. It's sort of my model of how complex the world is, but the world is a lot more complex than that. But the world is made out of, everything is made out of littler things, and those littler things are made out of littler things, and so forth. And those things are nested inside bigger things, and so forth. And where you perceive on that level of abstraction is somewhat arbitrary. It has to be bounded by your goals. That's the other thing, is that your perceptual structures are determined by the goals that you have at hand. I mean, some of that's not completely true, because your perceptual systems also have limitations, right? There's things you can't see or hear even if you need to. So there are limitations built in, but within that set of limitations, you're still trying to tune your perceptions to your motivated goals. And that's also very useful to think about when you're trying to understand artificial intelligence, because for human beings, without goals, there's no perception. Because there's no filtering mechanism that you can use to determine the level of resolution at which you perceive. Anyway, so there's a thing made of smaller things which are made out of smaller things. And it's kind of my iconic representation of the complexity of the world. And then you could think, well, what is this? How can you see this object? And I think if you just look at it, you can detect, it's like a Necker cube, you know, those cubes that are line drawings that you can see the front of and then it'll flip to the back. Have you seen those? So this is kind of Necker cube-like, or at least it is for me, in that when I look at it, my perceptions play around with it. Sometimes I focus on the kind of cross-like shape in the middle, and sometimes I can see these other lines, and then sometimes I'll focus on that square, and sometimes I can see the little dots there, or maybe one dot, and my perceptions are going like this, trying to fit a pattern to it. And you can kind of detect that when you're watching it. And so I would say, well, you have the options of perceiving this in its full complexity, or you can simplify it. Essentially, there's lots of ways you can simplify it, but some of them are laid out there. So you take the complex thing, you make a low resolution representation of it. So that's the rough area that all those dots occupy. That's the rough area broken down to its 4 most fundamental quadrants. That might be how you would look at it if this was a map of an orchard and you were trying to walk from south to north. That would be a useful representation. This combines this and this. That's that's the highest level of resolution that you can perceive this object at. That's lower resolution than the object itself. So the first issue is, how should you look at things? Well, that's a problem that intelligence has to solve. So that's one of the problems that intelligence goes after. And then I think what happens is we have the thing in itself, and then we simplify it with a perception, and that's like an iconic representation, and then we nail the iconic representation with a word. And that's how we compress the world's complexity into something that we can manage. We take the complex thing, make it into an icon, and represent the icon with a word. And then when I throw you the word, so to speak, you decompose it into the icon and then decompose it even further into the thing, if you know the icon and you know the thing. And so then we can use shorthand, right? Because you have representational structures and so do I, and I'm just tossing you markers about your representational structures and you can unfold them. That's what you do when you're reading a novel, because the novel comes alive in your imagination in your own idiosyncratic way. And it wouldn't if you didn't understand the references of the novel, right? The novelist has to assume that your basic perceptual structures and your intuitions and your instincts are basically the same as his or hers, because otherwise they have to assume that, because otherwise they would be lost in an infinite regressive explanation. So, and it's problematic often. For example, if you start reading Victorian novels, you may find that it takes a while to get into them because the presuppositions, the expectations are slightly different, and so is the language. You have to update the representations. But anyway, so that's roughly, as far as I'm concerned, that's roughly a representation of what intelligence is doing in the world. Or a big part of it. It's how in the world do you look at things so that you can use them for the purposes that you need to use them for. And then the next problem that intelligence has to solve, which is related, is once you've got the perceptual landscape sorted out, how do you abstractly represent the action patterns that you're going to implement in the world? So it's, how do you perceive where you are now? How do you perceive where you're going? And how do you construct up and then implement strategies that enable you to move from where you are to where you're going? So it's a continual process of mapping and movement. And so it's navigation. That's what we're doing in the world all the time, is navigating through it, because we're mobile creatures. We're navigating through it, attempting to make the world manifest itself in accordance with our wishes. And that's the fundamental problem that intelligence has to solve. And animals have their perceptions to rely on, but we have our perceptions and our ability to abstract from those perceptions multiple times and then to abstract finally into language. So we live in a very abstracted world. And it also means that we can learn a lesson in one place and generalize it across many other places, which is also something that animals have a hard time doing, because they don't know how to do that initial perceptual generalization. So okay, so then the question might be, well, if intelligence has to solve the problem of how to perceive and navigate within the world towards ends, in order to fulfill, in order to make the world manifest what it needs to manifest so that you can maintain yourself and stay alive, what ends is it orienting itself towards? And I think that's a good way of thinking about the traits. The traits motivate the perceptual frame. And so you might think that, well, extroverted people are after social success. And you can understand why that would be, because social success brings with it all sorts of rewards. Social failure brings costs, and you could also understand why that would frighten you away from it. And social success also requires the expenditure of effort, and introverted people seem to be much more conservative in a sense in terms of expending energy socially, and I suppose they're protecting themselves to some degree against the possibility of social failure. We don't really know. We know more about how extroverts, in some sense, how and why extroverts orient themselves the way they do in the world. We're not so sure about introverts. What it is that, what the proper landscape is for introverts. I can show you a word cloud. I'll do that at some point, that were generated from introverts on Facebook. And they seem to be into fantasy and gaming a lot. And I don't know why that is exactly, because the fantasy element should be more localized in openness, but the introverted types, I mean, I suppose they're the people that are on the Big Bang Theory, roughly speaking. You know, they seem to be the introverted types, and but we don't understand that much about them, exactly how it is that they're orienting themselves in the world. People who are high in neuroticism are oriented towards security and safety. Agreeable people versus disagreeable people are oriented, say, towards cooperation versus competition. Conscientious people are oriented towards order, duty, obligation, and implementation. And open people are oriented towards abstraction, in both ideational and in representation. And so those are also, to some degree, you might also think about those as value systems, right? Because what you value is definitely not only what you pursue, that's too narrow a view. Value is also what you perceive and pursue. And so thinking about these things as this entire frame of reference, I think, is a much better way of doing it. We talked about this earlier, this sort of structure earlier, as a micro-personality. And I mentioned the determination of micro-personalities by fundamental underlying biological systems like defensive aggression and sexual desire and hunger and thirst and so forth. Those are all systems that can grab your perceptions, make you look at the world in a certain way, make you pursue something else in a certain way, and prime action responses that are in keeping with all of that. The traits seem to be something like higher order agglomerations of those more fundamental biological motivations. Although we don't quite understand the relationship between the underlying biology and the traits, we're starting to sort it out. So we know, for example, if you look at the function of the hypothalamus regulates the basic biological motivations that I just outlined, but it's also the place where the exploratory systems find their ultimate physiological grounding, and openness and extroversion seem to be variant manifestations of the exploratory impulse, and that's grounded in the hypothalamus. So we're starting to be able to put the traits, to sort of nail the traits down to their underlying biology. And with regards to neuroticism, well, if you're high in neuroticism, you're more sensitive to anxiety, and that's regulated at least in part by the hippocampus and generated in part by the amygdala. There's another part of the brain called the periaqueductal gray that seems to be associated with the experience of pain, and pain is quite a complex phenomena. Depression is pain-like, grief is pain-like, social isolation is pain-like, disappointment is pain-like. There's anxiety components to that too. And so neuroticism seems to be something like threshold for activation in those negative emotion systems. So if you're higher in neuroticism, 1 unit of uncertainty might produce, let's say, 3 units of psychophysiological response, whereas if you're lower in neuroticism, 1 unit of uncertainty might produce 1 unit of psychophysiological response. It's hard, you know, obviously that's a simplified schemata, but there's variability because if something unexpected or threatening happens to you, it isn't obvious how upset you should get. One answer might be, brush it off, it's nothing. Another answer might be, it's a bloody catastrophe. And often when something uncertain or threatening occurs, you don't have enough information at your disposal to make a full determination of the potential import of the circumstance, especially if it's uncertain. And so then you have to guess at how upset you should be and where you are on the normal distribution with regards to trait neuroticism, say, that sort of determines what your guess on average is going to be. So, you know, with conscientiousness, say, you might say, well, how hard should you work? Well, that's a really difficult question. If you're going to die tomorrow, and then you probably shouldn't work very hard today at all. So one thing you might say is that the degree to which you should work hard is dependent on your assumptions about the stability of the future. We actually know this to be true because if you put people in wildly uncertain circumstances, they discount the future, which is exactly what you should do, right? It only makes sense to store up goods for future consumption if the future is likely to be very similar to the past and the present. You need a stable society for that. And conscientiousness only works in a stable society, because all you do otherwise, if you're piling up goods, which is kind of what conscientious people do, is leaving them there for the criminals to take, or waiting for the next chaotic upheaval to wipe out everything that you've stored. And so even conscientiousness is a kind of guess. Hardworking people say, well, you know, sacrifice the present for the future. That's great, as long as the future is going to be there and you can predict it. But if it's not going to be there and it's unpredictable, then the right response is take what you can take right now while the getting's good. Now, you know, obviously there are troubles with that too, and I'm speaking, you know, I'm offering rough rules of thumb, but I'm trying to provide you with some indication of how and why these difference in value structures exist, because they're applicable in different environments. You know, sometimes in a dangerous social environment, it's not obvious that being an extroverted person is a good idea, because extroverted people, they stand out, especially if they're extroverted and creative, right? Because not only are they noisy and dominant and assertive, they're also colorful and flamboyant and provocative. Well, that's great if you're in a society that rewards that sort of thing, but if you have, you know, if you're ruled by an authoritarian king who wants absolutely no threat whatsoever to his stability ever, then dressing in gray and shutting the hell up is a really good survival tactic. So the utility of the trait depends on the structure of the environment that surrounds it. And that's why there's variability in traits. And so you have to be careful when you're thinking about it from a strict scientific perspective to make the assumption that positioning at any place on the normal distribution is preferable to positioning anywhere else. Now, one exception to that might be IQ. Because one of the things that you can see with IQ is that people with higher IQs seem to do better, but that's also only true in complex societies. And then there's another problem that seems to emerge with IQ, and I don't know exactly what to make of this, but we know that as women's IQ increases, the probability that they're going to remain without a mate also increases, because women tend to mate across or up dominance hierarchies. And so if you're a woman with an IQ of 130, then you've already eliminated about 95% of the men. And that's only using one criteria. That's just straight intelligence. And so there also might be limitations to the utility of intelligence with regards to reproduction that we don't really understand very well yet. So anyway, so you get the point. So there's these underlying, I kind of put down two value structures there. Capitalize on social groups, that would be an extroverted value structure, say, and maintain order, that would be a conscientious strategy. And conscientious people are going to want to maintain order because they don't want things to shift across time, because if they shift too much across time, then the things that have been stored up for the future start to become increasingly irrelevant. There's lots of other reasons to maintain order as well, but that's one of them. So, all right, so that your cognitive ability allows you to do modeling. Now, this is where human beings have leaped ahead of their competition. So animals can think, but it isn't exactly obvious how they think. They think strategically. I think they think the same way that children think, in some sense, when they're playing with Legos, when they're not thinking about the Legos, you know, when they're just moving them around. We know, like, if you watch a smart predator group like lions go after their target, or watch chimpanzees hunt down a monkey, you can see intelligence at work, because hunting behavior is very, very complicated, obviously, you know, especially if you're chasing something intelligent. But there isn't that level of abstract representation. So let's look at this. So here's a picture of the human brain with someone facing this way, right? So here's the primary motor cortex. Okay, so you're using that to voluntarily move your body. Okay, now Then I might say to you, close your eyes and imagine doing something. So just close your eyes and imagine picking up the cup that's in front of you and just visualize it. Okay, so then you might say, well, what part of your brain are you using then? And the answer is use part of this part because that's where you have your body represented. But use this part here, the premotor cortex, to envision potential actions. Now what's happened is that this part of the brain evolved out of this part. And that makes sense because the first part is just how you would move, but the second part is how you would think about how you would move. And then the next part, which is this part, huge in human beings, is how you would think about how you would think about how you would move. So, because that enables you to start to do extraordinarily abstract planning. So I could say, well, envision how you would pick up the cup. And obviously that's something that you've separated out as a potential simulation from the actual action. But we can talk about extraordinarily high-level abstractions that have effects across multiple specific domains way into the future. And the more abstract that your manipulations become, the more they seem to be moved away, say, from the primary motor cortex out into the prefrontal cortex. Hierarchies of abstraction. And the reason for that, as this was Karl Popper, this is really, really worth thinking about. Why think? Let's say you're an animal and you act and it doesn't go very well, and then you die. Well, you've learned that acting that way didn't work, but now you're dead. So that's not that helpful. And then you might think, well, maybe you should represent how you're going to act. So, you know, here's a box with a snake in it and your coffee cup is inside the box with the snake in it. And I say to you, imagine picking up the coffee cup, and you imagine it and you think, oh, I'll pick up that coffee cup and then the snake will bite me and I'll die. And so then you decide that implementing the strategy of picking up the coffee cup is probably not a very good idea. And so that stupid idea has to die and not you. And so Popper's idea was that the reason that we developed the capacity to abstract was so that our stupid ideas could die instead of us. And that's really, it's almost impossible to overstate how brilliant an observation that is. Because what it means is that, like, as a standard animal, you would have to produce variants of yourself reproductively to go out into the world and try their hand at survival. And that's pretty costly because you have to produce all the biological replications of you, so you could only probably manage that maybe 13 times if you really, really worked at it. And then the cost of their failure is extraordinarily high because they die. Well, you can just sit there and produce like 20 different versions of you extending out over the next week or the next month, and you can run them through a simulation and kill off all the ones that you don't regard as suitable and then only implement the successful ones. Now, you know, you could debate about how accurate you might be at doing that because it would depend on your knowledge. But we do know that intelligent people tend to do better across the course of their life. And so it does seem that there is some utility with regards to survival, or at least with regards to positioning in the dominance hierarchy, which is somewhat of a proxy for survival and for reproductive success. There's some association between that and the ability to abstract. So we could say that part of the reason that people got smarter was because smarter people were more likely to stay alive. Now, I think it's more complicated than that too, because I believe that human males and females are in an evolutionary cognitive arms race, roughly speaking. And so as men get trickier, women get trickier to understand them. And then as women get trickier to understand, men get trickier to understand them. And so we've been chasing each other around this cortical expansion loop pretty much since we parted ways with the ancestor that we had in common with chimpanzees. And so that's roughly about 7 million years ago. We've undergone a tremendous cortical expansion since then. And there's lots of reasons that have been propelling that. So what do you have to do when you're thinking? Well, you have to figure out where you are and how to see that. You have to figure out where you're going and what that should be. And then you have to generate and represent appropriate action strategies and simulate those in time and space. And then one of the things that's worth noting is that's what you do when you read a story or when you tell a story. And so part of the reason that you like to read stories is because that's exactly what stories are telling you how someone is going about doing that. And so then you can see how, if you think about preference for fiction, which is actually part of openness. Preference for fiction, the utility in fiction is that it allows you to experience a plethora of simulated worlds and to embody the consequences in abstraction without having to go through the trouble of doing that for yourself. And we do know there's good empirical literature now showing, some of it done by ex-students from my lab, showing that reading fiction does improve your interpersonal intelligence, for example, your ability to understand the position of other people. Logically enough, because that's what you're doing when you're reading. So, okay, so I'm trying to give you some background so that you can understand what it means to abstract and also why it's useful, because we need that in order to move forward with the idea of intelligence. So here we go. Okay, so that's how you act voluntarily, and then that's how you represent how you act voluntarily, and then that's how you think about how you represent acting voluntarily. And the reason I'm telling you this is because it's useful to think about intelligence as abstract action, because we tend to think about intelligence as abstract representation, right? Intelligence is the manipulation of facts or the understanding of facts. But if you look at it neurologically, I would say that's a misapprehension, because the part of the brain that does the highest level of abstract thinking is actually something that's emerged from the motor cortex. Now, that doesn't mean you don't use your intelligence to represent. You do. But the purpose of intelligence is to represent potential action patterns. And we're embodied creatures and we need to move in the world. And so that's the proper, as far as I'm concerned, that's the proper way to conceptualize intelligence. So, and here's a study. I'll read you the study. Imagery in the premotor cortex. Well, studies on healthy subjects have shown a partial overlap between the motor execution and motor imagery neural circuits. Few have investigated brain activity during motor imagery in stroke patients with hemiparesis. So a partial overlap between the motor execution and motor imagery neural circuits. Well, here's an interesting side consequence of that. So let's say I'm thirsty and I look at that glass of water, and part of what happens when I look at the glass of water is that my eyes activate this directly. So, you know, I've already talked to you to some degree about how your eyes work, right? There's patterns there out there in the world. The patterns are mapped onto the retina, so it's a pattern display matrix. And then that pattern is propagated along the optic nerve, and then that pattern manifests itself in the visual cortex, and then that pattern manifests itself in the motor cortex, and it manifests itself in bodily movement or preparation for bodily movement. Technically, you don't need conscious imagery for that to happen. Now, that's something really useful to know, is that your eyes can activate your body without you being aware of the image, because you think, there's the world, I see it, then I determine how to act. It's like, yes, but also no. There's the world, and seeing it prepares me to act. Forget about the damn imagery. So when I look at that cup, part of the act of looking at it is preparing that gesture. And that's especially the case if I also happen to be thirsty, because if I'm thirsty, the cup signifies something that I can use to quench my thirst, which makes it a very different thing than what it is when it's empty or when I'm not thirsty. So I'm not even going to use the same part of my brain to perceive it, because it's not the same thing in relationship to me. So I look at it, and then just understanding the size of it, there's not much difference between understanding the size of it and doing this. So let's see how I got that. So that's pretty good. So that's when you ask, well, what does it mean to understand something? Well, that's what it means. Insofar as this is a cup, because it could be tinder for lighting a fire, for example, or something to stomp on to make a noise. Insofar as it's a cup, then understanding it means pattern mapping it onto exactly this. And if I do that successfully, then I get a little reward, a little hint, a little kick of dopamine. And that dopamine makes me feel a little bit better, but it also bathes the neural tissue that I use to make that perceptual, to structure that perception, and also to undertake that act, and it makes it just a little bit more likely that I'll see it that way and act that way in its presence again. And that's how you learn, right? You lay out a perceptual scheme, it's got a goal. If the perceptual scheme and its associated action patterns make the goal manifest itself, then you get a little burst of positive emotion, click. then that makes it, those little the neural circuits that instantiated that thrive a little bit and get a little bit more predominant. And that's also why you got to watch yourself if you're taking psychomotor stimulants like cocaine or alcohol, even for that matter, because they produce hyper learning. And so, you know, I'll glance at that and maybe it'll trigger off a bit of thirst. But if I was a cocaine addict and that was cocaine paraphernalia and I glanced at it, it was like, whap, that thing that I've built in my head out of repeated, you know, massive hits of dopamine is going to grab my perceptual structures and my actions and bring me, that'll be that craving, which is an impulse to move forward towards it. You'll feel that instantiated in your body. That's the craving. It's very, very difficult to get rid of that. Even if you're a cocaine abuser and you've gone to a treatment center for several weeks and got over the worst of the, at least initial parts of the relearning not to abuse, the second you go back into your natural environment and take a look at the cues, bang, that thing will be right back there directing your action. And what happens is when one of those perceptual systems comes up, you can see this when you're hungry, it suppresses all the other potential perceptual systems. You can see this when you're angry too, right? You get angry and you're angry with your partner and all you can think of is all the stupid things they've done for the last 10 years. You don't even remember that you like them. It's like you could remind them, I know you're mad, but remember you like me. Well, not right now. You know, so it shows you how those micro personalities can dominate and suppress. That's what happens. Because if they didn't suppress the other micro personalities, they wouldn't be able to run themselves to conclusion. And then you'd never get what you want. Okay, so anyways, studies have shown a partial overlap between the motor execution and motor imagery neural circuits. So what happens is you see something and it primes you for the appropriate action. Few have investigated brain activity during motor imagery in stroke patients with hemiparesis. Hemiparesis is motor impairment from the stroke. This work is aimed at examining similarities between motor imagery and execution in a group of stroke patients. 11 patients were asked to perform a visuomotor tracking task by either physically or mentally tracking a sine wave force target using their thumb and index finger. So they're doing this during fMRI scanning. Results: whole brain analysis confirmed shared neural substrates between motor imagery and motor execution in bilateral premotor cortex. So that's the part that I was talking about. I won't tell you about the rest of the brain. Parietal lobule is partly associated with body recognition. So basically, I showed you that study because it's one of the studies that lend credence to what I was just describing, is that imagery is the precursor to action, and that it's associated. You get the imagery going here and the action there. Think about thinking, think, act. That's roughly how it works. Okay, now down to cognitive ability. Well, how can you conceptualize intelligence? Well, this is a major problem because your initial conceptualization determines in part the strategies that you're going to use to investigate intelligence. And when you pare a sentence down to what is intelligence, the sentence is problematic because part of it is a question about if and how such a thing might manifest itself in the world. So there's a fact out there or a set of facts that corresponds to intelligence, but the other problem is, well, what do you mean when you say intelligence? And you kind of have to nail that down if you're going to have a conversation about intelligence that doesn't go entirely astray. And so you've got a definitional problem as well as an empirical problem. And so there have been, and this was especially true in the 1990s, people have been studying intelligence, IQ intelligence, since the 1920s, and it is a very well-established branch of psychology. One of the things I have to tell you about IQ research is that if you don't buy IQ research, you might as well throw away all the rest of psychology. And the reason for that is that the psychologists, first of all, who developed intelligence testing were among the early psychologists who instantiated the statistical techniques that all psychologists use to verify and test all of their hypotheses. So you end up throwing the baby out with the bathwater. And the IQ people have defined intelligence in a more stringent and accurate way than we've been able to define almost any other psychological construct. And so if you toss out the one that's most well defined, then you're kind of stuck with the problem of what are you going to do with all the ones that you have left over that are nowhere near as well defined or as well measured or whose predictive validity is much less and has been demonstrated with much less vigor and clarity. Anyways, despite all that, people have posited a number of different intelligences, and reasonably so, because if you think of intelligence as that which might move you forward successfully in the world, obviously there's a fair number of phenomena that are associated with individuals that might fit into that category. So we have people have made these distinctions. Bob Sternberg, for example, has distinguished between practical versus analytical intelligence, and he kind of thinks of practical as like street smarts, and has attempted to dissociate that from the kind of analytical intelligence that that characterizes more straight IQ research. I don't think he's done it successfully as well at all, and since the 1990s, interest in his practical intelligence has declined precipitously, because when it is matched head-to-head with standard IQ intelligence, the IQ intelligence eats up all the variability. What's really happened, as far as I can tell so far, is that when we're trying to predict people's course through life, IQ does a very good job, and then one of the traits does a very good job as well, which is conscientiousness. But it doesn't do as good a job as IQ. Now that partly might be because we can't measure conscientiousness very well. We're stuck with self-reports, or maybe I could gather peer reports about you, or I could gather your parents' reports about your teachers' reports, and each of those seems to pick up a little bit more of the pattern, because you know yourself, but other people know you differently than you know yourself, and there's still some accuracy in that. You can get multiple rater reports of something like conscientiousness, and that'll up its predictive validity. But in the final analysis, the best you seem to be able to do with conscientiousness is about a 0.4 correlation with long-term performance, whereas with IQ, in complex jobs, you can probably get 0.5 and maybe 0.6. And so 0.5 is 25% of the variance. You got to square it. 0.6 is 36% of the variance, and 0.4 is 16% of the variance. So even at the low end, let's say high end for conscientiousness is 0.4 or 16%. Low end for IQ is 0.5 or 25%. Low end estimates of IQ make it 1.5 times more powerful than the high end estimates of conscientiousness. And I think that's about right. You'd think, why do we even have to debate this? And because it's so bloody obvious to me that intelligence is a major predictor of life success. I mean, you people, I've measured the IQ of University of Toronto people. You know, people in this room who have an IQ of less than 120 are rare. Well, why? Well, smart people go to university. Now, is that actually a contentious statement? Well, it shouldn't be a contentious statement. It's self-evident. Universities were actually set up so that smart people could expand their abilities. That's why they were there. And you're selected on the basis of assessments that are essentially there to assess something like intelligence.
Maybe what the controversy is that whatever they're measuring is intelligence. So being able to perform those specific puzzles.
Yes, but that is part of the controversy. Is it reasonable? And this is a measurement issue. And that's why I've been instructing you to some degree in psychometrics, because we actually know how to do this. We know how to answer that question. So let's take a look at how intelligence has been assessed and why, and then you can make up your own mind. Anyways, here's some of the examples of other forms of intelligence. And so then the question is, well, what does it mean to have a different form of intelligence? Would form A and form B be completely uncorrelated? Like extroversion, say, and neuroticism, or would they be slightly correlated, or would they be highly correlated? And then you might ask, well, how highly correlated do they have to be before they're the same thing? Or how uncorrelated do they have to be before they're different things? And actually the answer to that comes down to something like practical utility. It's like, imagine I'm trying to figure out how well you'll do in university. And I measure one thing, and it's correlated at 0.7 with another thing I measure about you. Then I might say, well, are those two things the same or different? They're pretty highly correlated. You're high in one, it means you're going to be high in the other. Well, so is there any utility in measuring both things? And the way you figure that out actually is you do it statistically. So we take the target, which might be your performance across university. And then we say, well, can we predict your performance across university better by using one variable or two variables? So we would enter them both into a regression equation. All a regression equation does, it's quite simple. So you're trying to predict a target, and the regression equation tells you how well you can predict that target if you know another fact. Now then it gets a little complicated because that's a correlation. How well you can predict B with A. Well, a regression will say how much you can predict C if you know A and B, or A and B and C and D and E, because you can use multiple predictors, and you can weight them. So it might be 2 times A plus 1 times B equals C. And that's all a regression equation does. It's just multiplication and addition. Very, very straightforward. And so two variables are sufficiently different functionally if you can use both of them simultaneously to predict something of interest. So again, it's a tool-like approach. This is how the psychometricians do it. Is something real? Well, it's real if you can measure it and it helps you predict. That's how it's defined. So then you might say, well, are there these multiple intelligences? Well, the first question would be, well, what do you mean by are there? And the answer to that would be, well, let's specify the question, since we're going to be scientific about it. Let's predict how well people do in university. We'll start with the assumption that if intelligence isn't associated with university success, then you're probably not talking about intelligence. Now you could argue that, right? Because you could say, well, intelligence has nothing to do with university success. But that's a definitional matter. We'd have to agree to begin with. Is it reasonable to start with the presupposition that intelligence and university success share something in common? Well, I think you have to be daft to deny that initial proposition, although you could. Because you could say it was privilege or socioeconomic status or any number of sociological phenomena, and some of those are obviously relevant. Social class, for example. Because, you know, if you're in a higher social class, and all things being equal, intelligence included, if you're in a higher social class, you're more likely to go to university than you are if you're in a lower social class. So there's other factors that are going to influence whether or not you do well in university, but we're going to assume that one of them might be intelligence. Well, then you would ask, well, if you measured social intelligence, so that's, what do they call that? Social intelligence? No, emotional intelligence, which does not exist, by the way. Emotional intelligence, moral intelligence, linguistic, musical, logical, mathematical, spatial, body kinesthetic, interpersonal, and interpersonal. All different forms of intelligence. Okay, so to answer the question of whether they exist, what you do first is pick a target, prediction of university performance. Then you make a measure for each of them. Then you test to see if the measure measured the same thing across multiple instances within the same person. That's a reliability test, because what the hell good is your ruler if it stretches when you use it? It has to measure the same thing multiple times. And then you would say, okay, we'll take all these different intelligences measured the way we've decided to measure them. The first thing we'll do is see how highly correlated they are, because if they're two of them are completely correlated, then you have one, you don't have two, because that's virtually the definition of one instead of two. You can factor analyze them and see if you can pull out what's common across all of them. That's another thing, because then you might say, well, intelligence is what's common across all the measures of these intelligences. It's a proposition, it's not a fact. You have to decide if you're going to agree with it. But that, if you were going to do that, you'd use a factor analysis. And you'd say, well, if someone was more likely to be musical, if they were also high in linguistic ability, and more likely to be logical and mathematically inclined if they had high spatial ability, etc., then you'd be hypothesizing that there was one factor behind all of those manifestations that's somehow similar. And maybe there wouldn't be. And then you'd take all your measures and you'd put them in something like a multiple regression analysis, and you'd predict your target, university performance. And then maybe you'd say, well, wait a minute, let's not just use university performance. Let's use junior high performance, high school performance, university performance, and job success. And then let's say that the only things that predict success across all of those categories and that are the same we're going to define as intelligence. Well, that's basically how you end up with IQ. You could say that IQ is what's common across all possible sets of intelligence tests. Now, people are going to debate that, because you still have to define what constitutes a test. But the way the psychometricians have managed it, and have taken care of this at least to some degree, is to say, well, we're not going to define everything that we measure as intelligence. So extroverted people are more socially fluent. Are we going to call that intelligence? No. We're going to call that personality. We're going to call that extroversion. And we're going to call stress tolerance. You could say, well, if you can tolerate more stress, you're more intelligent. It's like, well, no, that isn't how we've defined it. We're going to define that as being lower in neuroticism. If you're cooperative, you're more intelligent. That's emotional intelligence. Well, what? You're less intelligent if you're competitive? Well, no. So we've parsed that off to agreeableness. So then the question might be, is there anything left of these so-called intelligences once you control for personality and IQ? And the answer is no. Nothing. Nothing left of them. And the people who keep pushing these ideas keep trying to push them because they don't like the idea of real individual differences. And to me, that's just a matter of sticking your damn head in the sand, because it's obvious. Here, you're going to have a child. You want the child to have an IQ of 65 or 145. Decide. Okay, so you're all going to vote. Okay, you think any one of you is going to vote to have a child with an IQ of 65. That child's going to have a hard time developing even linguistic ability. They're never going to learn to read, right? They're never going to leave home, in all likelihood. So which child are you going to pick? Well, so do you believe in intelligence or not? Well, obviously, if you have any sense.
So let's say we took off all the labels and we just, for every time something statistically came out as a 1,
Yeah.
we just gave it a letter label, like A,
Yeah.
B, C, D. So all these things just have their statistical validity and just names. So then if we're going to assign names to them after, are we assigning the names based on what we consider to be reasonable?
Okay, that's a good question. So look, here's one thing. So let's say this is actually what happened when people developed the Big Five. So I'm going to give a very large number of people every question, a huge set of questions that cover every element of their personality I can think of. It's agnostic, right? What I'm really trying to do is come up with the biggest possible set of descriptors that someone could actually fill out. That's a limit. I can't give you 10,000 questions. That's just, so maybe I'd take a set of 10,000 questions and randomly select a few sets of 100, right? Because then I would have represented the entire set. Then I give them to 1,000 people, agnostically. Then I do the factor analysis. Bang, 5 factors come out. And then the factor analysis tells me which questions load on each factor. And what the factor analysis is saying, here's 20 questions, and there's something about them that's the same. So then I read the questions and I think, well, those questions are referring to something the same. What is that? Well, then maybe I talk to 3 colleagues and we think, well, that's something like sociability. Bang, we have a name. And then we could go see, now that we have a measure of sociability, we could go associate it with other measures of sociability. Like we might say, well, are people who score high on this measure of sociability more likely to go to parties? And the answer would be yes. Because what happens if you take 10,000 questions about personality and randomly select sets of 100 and give each of them to 1,000 people and do a factor analysis, the first factor is extroversion. And it's the factor in human personality that seems to pick up the biggest amount of variance. And so then we say, from a statistical perspective, extroversion is real. But we define real. Real means that if you use linguistic representation, randomly applied across large sets of people, and you factor analyze it, these come out as clumped together. Because you have to define what constitutes real if you're going to play the this is real game, which is basically what you're doing in science. And so that's what happened with the Big Five, and then people started to look, well, okay, is there a biological substrate for this? Bang, turns out there is. Incentive reward, that's the positive reward system. So, and then, well, neuroticism, that's often, but not always, the second factor. Well, is there a biological basis for it? Yes. Threat sensitivity and pain sensitivity, they seem to lock together. Agreeableness, that's the care system that Jaak Panksepp has identified. So that's basically maternality. It's something like that. You had another question.
There seems to be a difference in the way intelligence is measured and all these personality constructs are measured, where the personality constructs are about linguistic representation.
Yeah.
People agreeing on linguistic, but intelligence is like an applied.
Well, it's because we found out how to measure intelligence. So, and I'll get into that right now. So then the question is, well, how do you measure intelligence? Okay, well, it's similar. It's similar to this linguistic approach, but here's how it differs. Generate 10,000 questions that require knowledge, and you get 50 people to do it and have them be of diverse opinions about what constitutes knowledge. So much the better. Then you cover that. You want to oversample the territory. So you want to have some questions in there that only one person out of 50 would think that measures intelligence. Because you can oversample. The statistics will take care of that. So you want to ask more questions than you think are reasonable. And that's part of the way that you get rid of bias in the sampling. It's like, you think, go find out 10 questions that someone could answer if you think they're intelligent. I don't care what they are. And then 50 of you do that. Bring me the questions. Well, let's say we get a nice set of 10,000 questions. Then we can take random sets of 100 and give them to 1,000 people. And then we can score their answers to the questions. And then we can rank order. We could say correlate their performance across different sets of questions. So I give you one set of 100 questions, you score 90. I give you another set of questions, you score, so 90 out of 100, you score 10 out of 100. Well, then we would think, if a bunch of people did that, those aren't measuring the same thing. Because if you're high on one, you should be high on all of them. Well, with IQ, it's like, if you do that, the reliability is like 0.9. It's unbelievable. You take one set of 100 questions, you rank order people. You take another set of 100 questions, you rank order people. You correlate the rank orders, it's like this. It's 0.9. The people who did well on one do well on all of them. The people who did bad on one do bad on all of them. That's IQ. Or more technically, this is what IQ is. Take 1,000 people and give them 20 tests of 100 items and then factor analyze the 20 tests and extract out the central factor. That's G. That's fluid intelligence. So then what do you do with that? Well, then you can try to use it. Then you can see, well, is there a biological basis for this? Is there something about, if you're higher in the ability to operate across these sets of questions, are there things about you that are physiologically different? And the answer to that is yes. Your reaction time is faster. Just simple reaction time. So light turns on, you push a button. Light turns on, you push a button. Okay? There's a lag between the light going on and you pushing the button. The shorter the lag, the smarter you are. Well, what is it? And that's really interesting because, you know, if you're perceiving something complex, it takes a lot of neural connections to generate the perception. But simple reaction time is like 2 neurons, whack. There's no complexity in that at all. And yet, how fast you are at that is still correlated, only at about 0.25, but that's not trivial. If you're doing research in psychology, generally speaking, and you come out with a 0.25 correlation between whatever you're measuring and whatever you're interested in, you're having a pretty good day. 0.25 is not bad at all. And so it's not accounting for all of it, but it's accounting for a fair bit of it. How big your head is, that's also correlated. How big your brain is physically, and then even more accurately, how big your brain is in relationship to your body. Now again, these are small correlations, but they're not non-significant. What else? Peripheral nerve conduction velocity, that's this study. 2 studies with sample sizes of 90 and 90, roughly speaking, are reported that investigated relationships among measures of intelligence, speed of information processing, and peripheral nerve conduction velocity. In both studies, neural conduction velocity was significantly correlated with IQ scores, 0.42 and 0.48. Man, that's a whopping correlation. How do I know that? Because a guy named Hemphill, where is he? Right there. You might say, well, how big is a correlation coefficient before you call it big? And the answer to that is, generally, let's guess. So if you talk to psychologists and they talk to you about how big effect sizes are, they used guesses that were generated by statisticians in the 50s. And so they radically underestimate the actual magnitude of correlation coefficients because they never studied it empirically. Well, this guy Hemphill, because how big is a correlation coefficient to be big? How do you answer that? Take 1,000 psychology studies, rank order the effect sizes, and break them into percentiles. Right? That's an empirical way of doing it. How big is the effect that the typical study generates? And then you can use that as a way of assessing how impressive the effect is that you generated. Okay, so this is it here. Hemphill, 2003, interpreting the magnitude of correlation coefficients. Now you could say that's a dopey way to do it because why define size in accordance with the size that people have discovered? And Hemphill would say, well, that's because I'm doing it this way with this paper. If you want to do it a different way, go right ahead. But there's utility in this. You come up with an R of 0.2. How likely is it that your next paper is going to have an effect size of that magnitude? How happy should you be? Well, the answer is a lot happier than you think. So To get an R of 0.5, that's 25% of the variance. So you still have 75% of what's ever explaining your phenomena left to be explained. R of 0.5, 90 to 97th percentile. So 19 out of 20 psychology studies that are published, and that's a hell of a lot more, fewer psychology studies than exist, right? Because a tiny fraction of them get published. 95% of them show a correlation coefficient of less than 0.5. For 0.35 to 0.50, that's greater than 75% of them. 0.15 to 0.35 is pretty typical. And the typical correlation between a personality trait and the target of interest is usually something in the neighborhood of 0.2 to 0.25. With IQ, you get up to 0.5. The relationship between income inequality and male homicide is like 0.75. It just covers all of it, which is to say that everywhere that everyone's poor, there's no male homicide. And everywhere that everyone's rich, there's no male homicide. But places where there's poor people and rich people, the male homicide rate goes way the hell up, right? Especially if it's a steep distribution, because the men at the bottom think, somebody has a lot more than me and that's not very fair. I'm going to do something about that. And that usually means killing other men. And so it's unbelievably powerful relationship. That's a useful thing to keep squirreled away in your imagination. Poverty does not cause crime. Relative poverty causes crime. That is a completely different thing. So, and it's dominance hierarchy issue fundamentally. It's men are generally the criminals. And as the dominance hierarchy gets harder to climb, the young men, especially the aggressive ones, get more likely to turn to violence. You really need to know that. It's an incredibly important fact. I'm going to interview the guy who figured that out, Martin Daly. I'm going to interview him for one of my podcasts in the next month or so. So you might be interested in tuning in on that if you're interested in this sort of thing. Okay, so back to these correlations. Look, peripheral nerve conduction velocity is correlated with IQ at like let's say 0.45. It's a whopping effect, man. And that's a pretty straightforward thing. Speed of electrical propagation along your neural tissue determines how intelligent you are. Well, is that really so surprising? You'd expect, if that's associated with neurological integrity, at least to some degree, it's exactly the sort of thing you'd expect. But it shows you how biologically based it is too. Faster neural conductance velocity was associated with higher IQ scores and faster speed of processing. Why? Who knows? Here's a hypothesis. If you're trying to remember a phone number, just the 7-digit one, what do you do when you're remembering the phone number? You say it over and over again, right? Or if you don't say it, you think it over and over again. And if someone distracts you, then you lose it. That's working memory, roughly speaking. And your working memory capacity, so imagine you could do 4 digits and remember them. You could do 6, you could do 8, you could do 12. Likely not. 12 is really pushing it. That's a great estimator of IQ, working memory. In fact, there's almost no neuropsychologists like to think that working memory is something in and of itself, but that's because they don't know a damn thing about psychometrics, generally speaking. There's almost no difference between fluid intelligence and working memory. And the reason for that is that all measures of intellectual function collapse into G. And so we can take a look at what that means. This is from this character here, Carroll, John Carroll. If you want to know everything there is to know about IQ, this is a book that everyone who's a psychologist you shouldn't be able to be a psychologist unless you've read this book, in my estimation. There's a couple of key texts, and this is one of them. This guy Carroll wrote this thick book. You don't have to read the whole thing because a lot of it's just, in some sense, demonstrations and proof of what he's saying. But what he did for IQ is the same thing that psychometricians did for the big 5. You've got the big 2 at the top. They're not very highly correlated. I think it's about 0.2, something like that. So they're pretty independent. And then they fragment into the big 5, and then you can differentiate them further into the big 10. And there really are 5 different traits because they're only correlated with each other at about 0.2 to 0.3. So they're really quite distinct. The question is, if you fractionate IQ, how correlated are the things that you fractionated into? And the answer to that is 0.8 or 0.9. There's one factor in IQ, roughly speaking. If you take, imagine that you took an IQ test and you took, it was 100 items long, and you took the 50 items that were the most correlated with each other, and then the 50 items that were the least correlated with those 50 items. So you broke it into 2, as much as you could. You maximally differentiated it. You might ask, well, how correlated would the scores be on those two different subsets? And the answer would be like 0.9. Because there isn't two things that you're measuring. Even if you break it up that way post hoc and say, well, it's unfair, but we're going to say because these are the 50 most highly correlated and these are the leftovers, like we're really capitalizing on chance there, you're still going to get an almost identical readout from both sections of the IQ test. And it's just not the same with personality. So this is Carroll's model basically. Stratum 3, that's the highest level of abstraction, that's fluid intelligence. And then you can break it down into these subcategories of cognitive ability. And you might say, well, how different are those subcategories? And the answer is not very. If you're high in one, you're very likely to be high in all of them. Now there's a bit of a coda to that, which is that the lower your IQ, the higher the correlation between these sub-aspects of intelligence. The lower your IQ, the higher the correlation between the sub-aspects of intelligence. As you get up into the higher strata of IQ, your intelligence differentiates more across the potential range of differentiation. Which is to say, there's one way of not being very bright, but there's multiple ways of being bright. So, but even so, if you're high on one, you're still quite likely to be high on the rest of them. So then the question is, what's the correlation between G and each of these sub-elements of G? And then what's the correlation between the sub-elements of G themselves? So if this was plasticity, and we were looking at openness and extroversion, the correlation here would be about I think it's about 0.5, something like that. And the correlation between openness and extroversion would be about 0.3, quite a bit of difference. But with this, there's G, there's the sub-elements, there's the correlation coefficients, 0.9, almost 0.95, what is that, 6 or 8? 8, 0.8, 0.6, 0.8, 0.8, 0.9 pretty much, 0.9 pretty much. Well, you can fractionate it the best you possibly can. It doesn't matter. It's one thing. It's one thing. And it looks like it's the ability to abstractly represent and then to manipulate the abstractions. I said with working memory, you know, you can get it that simply. How many digits can you keep in your head simultaneously without dropping one? That's it. God. It's unbelievable. It's pretty straightforward. And then it's this viciously powerful predictor of long-term life success, probably a prediction of around 0.5. Now, psychologists hate this. They won't admit that it exists. And I think it's because there's something about intelligence that rubs against our intrinsic egalitarianism, right? There's two things that do it. First, let's say you're successful. You like to think, I'm successful, you know, and you like to attribute it to your own doing. And fair enough, you know, I'm not saying that there isn't an element of it that's your own doing, whatever that means. But if your nerve conductive velocity happens to be high, there's a lot more probability that you're going to be successful. And it's kind of hard to blame that on you or to attribute it to you for that matter. So it indicates a kind of statistical arbitrariness about the distribution of success and failure in our society. Okay, so that's one thing. People don't like that idea. The second thing is that it turns out to be very difficult to raise IQ. Now, it's tricky because it looks like you can raise IQ across whole populations because at least fluid intelligence looks like it's been rising quite substantially over the last 100 years. Maybe as people are better nourished and better educated, but also more prone to continually manipulate abstractions in their life. Because I mean, kids start with computers when they're like 2, you know. So, but if you take a group of people and if you take a group of low IQ people and you try to raise their IQ, it's very, very difficult to manage it without a tremendous amount of investment. That doesn't necessarily mean the investment isn't worthwhile, but it does mean that it's very difficult. Well, the best thing to do, as far as we can tell, the best thing to do is get nourishment right. That seems to be the most effective. Yeah. So, and part of the reason, the theory is, part of the reason that population IQs have been increasing over the last 100 years is because there's just no one left who's seriously enough malnourished so that it's going to profoundly impact their intellectual capabilities. So breastfeeding seems to raise IQ. So it's 2 points, 3 points with every year of breastfeeding. It's something like that. So and that's actually quite a lot. 2 or 3 points actually makes a difference, as it turns out. So, okay. So is IQ real? Depends what you mean by real. IQ is averaged performance across averaged sets of questions that require abstraction to conceive of and answer. Is it real? Well, it's real statistically, and you can use it to predict important outcomes that other things can't predict. And from a scientific perspective, and it's also correlated with various physiological and biological phenomena. Well, that's how you define real scientifically. So yes, it's real. Are there other factors that determine people's success and worth? IQ isn't a measure of people's worth in any intrinsic sense. It's an estimate of their ability to succeed in hierarchies that are dependent on the ability to manipulate complex sets of information. There's lots of other things about people that differentiate them in terms of quality and quantity and all of those things. And the most evident of those are the big 5 traits. Now, if you're a psychologist, and this is another thing every psychologist should be taught, if you want to discover something about human beings that hasn't already been discovered, the first thing you should do is make sure it isn't IQ and it isn't any of the big 5 traits. And psychologists almost never do that, because what happens is that if they control for IQ, so in a regression you'd say, okay, here's the thing I'm interested in predicting. The first thing we're going to do is add IQ. And not a measure that you took in 5 minutes either, like a real IQ test, because you want to use a good measure to test your hypothesis against. And not a 10-item measure of the big 5 either, like a 100-item measure, so you get a reliable measure. You throw in IQ, you throw in the big 5, and then you throw in your dopey construct. And then you see if it can predict anything. And the answer is no. And so psychologists don't do it, because whenever they do it properly, it destroys their construct. And that makes them irritated, because their claim to their position of authority in the educational dominance hierarchy is predicated on the validity of their construct. Now, if you're a real scientist, what you try to do is destroy your construct. You think, okay, it looks like this is real. Then you think, it's probably not. And I don't want to spend the next 10 years chasing a ghost and a chimera. So I'm going to try to destroy the damn thing. So you say, well, we'll match it up against a good measure of IQ and a comprehensive big 5. And it still survives. We'll do a couple of replications to make sure that we can't kill it any other way. And maybe we'll do the statistics 3 or 4 different ways to make sure that the thing just doesn't disappear when you use a different statistical procedure. And people don't do that, and that's why the replication rate, even among well-established psychological findings, so to speak, ones that have been highly cited, is extraordinarily low. And if you talk to psychologists, they'll wave their hands and they'll say, well, I don't really believe in IQ. It's like, okay, you know, we're not talking about, what do you call those? What did the Ghostbusters hunt down? We're not talking about paranormal phenomena. They're not things you get to believe in or not, right? There are rules for defining what constitutes something that's real from a scientific perspective and a psychometric perspective. So you don't get to say, well, I'll apply one definition of reality because I don't like IQ, and then I'll use the same definition to justify my own constructs. Like, sorry, that isn't how it works. You can do that if you're a postmodernist, you can do that. But if you're a person who actually thinks scientifically, you don't get to play that game. So, now, you know, part of the reason that we need to know about these sorts of things, let's see, how are we doing for time here? Oh yeah, we're doing good. I think we need to know these things partly because they have policy implications. First of all, you need to know them for your own life, because you got to know that there are differences in intelligence. It's really important. If you go into a job and you're not smart enough for that job, you're going to have one bloody miserable time. And you're going to make life wretched for the people around you because you won't be able to handle the position. And as you climb hierarchies of competence, the demand on fluid intelligence increases. And so, unless you want to fail, you don't put yourself in over your head. Well, what's over your head? Well, that's a tricky thing to figure out. I mean, you have to figure that out with intelligence, you have to figure it out with conscientiousness, you have to figure it out with creativity, you have to figure out with stress tolerance, with agreeableness, because you want to go into a cooperative environment and not a competitive one if you're agreeable, and with neuroticism, you probably want to keep the stress level of your job relatively low, because those are all places that you can break down. And most people have at least one significant weakness in their intelligence personality makeup, and you got to be careful not to place yourself in a position where that's going to be a fatal flaw. But what you really want to do as far as I can tell, if you want to maximize your chances for both success and let's say well-being, is you want to find a strata of occupation in which you would have an intelligence that would put you in the upper quartile. That's perfect. Then you're a big fish in a small pond. And you don't want to be the stupidest guy in the room. It's a bloody rough place to be. So, and you probably don't want to be the smartest guy in the room either, because what that probably means is you should be in a different room, right? You should look at a place where if you're right at the top, you've mastered it. It's time to go somewhere where you're a little lower so that you've got something to climb up for. So, and if you're not hyper conscientious, for example, you're probably not going to want a job that you have to work 70 hours a week at, because you're just not wired up that way. You'd rather have some leisure, and like, more power to you. If that's how you're wired up, there's nothing wrong with having some leisure. But if you're someone who can't stand sitting around doing nothing ever, then maybe you can go into a job that's going to require you to work 75 hours a week. And almost all jobs that are at the top of complex dominance hierarchies require very high intelligence and insane levels of conscientiousness, as well, generally speaking, as pretty damn high levels of stress tolerance. You know, because that can knock you out too, because there's going to be sharp fluctuations in your career, generally speaking, at the higher levels of a structure, and you have to make very complicated decisions, often with very short time horizons. So you have to decide if that's what you want. Okay, so here's some IQ items. So this is from a test, roughly. It isn't from the direct test, but it's an analog of the Raven's progressive matrices. Now here's how the Raven's was derived. So imagine that you got your 100 questions, and you can take out the sum of those and call that IQ. Okay, so now you have a score. Then you can do a correlation between all of the items and that score, and you can find out which single item is the best predictor of the total score. Because you might see that question 39 has no correlation with the mean, with the average. You say, well, that isn't a very good question. You'd actually throw that out of the next test. But you'd say, well, item number 15 is correlated at 0.75 with the total score. So that's a good single item. So then imagine that you went across sets of IQ tests and you took out the best single item predictors of full-scale IQ. What you'd end up with is something like this. So the Raven's progressive matrices is a very good test of fluid intelligence. And it's relatively non-linguistic, which is also an advantage, right? Because imagine you wanted to assess the intelligence of a very diverse range of people, and they all came from different linguistic backgrounds. Well, as long as they can understand the instructions, which are almost self-evident, then they're going to be able to do this. Okay, so this is, you see, you have to guess, in case you didn't already figure this out, which you would have had you been using your intelligence and applying it, you're trying to replace the question mark with one of these. And so here's how you do it, roughly speaking. It's probably a working memory test, because you have to hold a variety of variables in imagination at the same time. Okay, so the first thing you see is every row has a star, a triangle, and a square. And each row has a dot, 2 dots, and 3 dots. And so every row has to have a triangle, square, and star, and 1, 2, or 3 dots. Okay, so this one, first of all, what's it missing in terms of shape? Triangle. Excellent. See, that's why you're at the U of T. And then, okay, and then what's it missing for dots? 2 dots. Excellent. So we do a little scan here and we say, oh, look, well, it could be that one, or it could be, that's it. It's that one. And so, is that right? Yes. Aren't we smart? No. That was easy. So no, you're not very smart if you figure that one out, because pretty much everybody can figure that one out. I think this next one is more difficult. Okay, so in the first row you see that there's 2 objects, each are different color, and they move together, right? They join. That one, they're separate there, they join, they're together. They're separate there, and they join there. So this one should be halfway in between those 2. And the other thing that happens is, let's see, this item actually might be incorrectly represented because the blue should be on the other side. Whatever. What's that? 3. Yes. Did they flip? Okay, well anyways, you see that it's 3. See, I'm not very bright because I've just lectured for an hour. Okay, so that was a more difficult item. And then this one is more difficult, if I remember correctly. So let's see. So they're all 3 different colors, so that has to be color. Then what's the other thing? The relationship between the colors change. So what's the answer? Ha, you're all scared to answer, aren't you? Because you might be wrong. Yeah. And the more anxious people are even less likely to answer. Number 3. Okay, so if you want to test someone's IQ, then you put together a nice batch of these at different levels of difficulty, and then you sum them, and then you rank order, and then you correct for age, and then you have IQ, and that's that. And then you can say, well, then you can sort people into the complexity of their occupations. And isn't that dismal and wretched? But it's true. So here you go. This is from the Wonderlic people. They're a commercial company that makes general cognitive ability tests, and it's often used by corporations, even though it's actually illegal. It's actually illegal to use IQ tests, but the Wonderlic doesn't promote themselves as testing IQ. I think it's general cognitive ability, which is the same thing, but whatever. The SATs, the GREs, the LSATs, all of those are IQ tests. So now they're more crystallized than fluid, and we'll get to that in a minute. But crystallized knowledge is what you accrue across time. So you could say that fluid intelligence is what programs your brain. It fills it with facts, let's say. It fills it with knowledge. And then, but you can get an estimate of your intelligence by sampling your domain of factual knowledge. And the reason for that is that, well, obviously, the better the programmer, the better the content. And so what that also means is that you could, if your prefrontal cortex was damaged later in life, your fluid IQ could plummet, but your crystallized IQ remain more or less intact. So even though they're not different, one produces the other, and then once the producer has produced, then the producer can disappear, and you still got the encoded knowledge. So at least that's how it looks to me. So, okay, so how smart do you have to be different things in life? Well, if you have an IQ of 116 to 130, which is 85th percentile and above, so it's 1 person in 8 up to 1 person in 130, I believe is 85, 90, 95, is it 95? I think it's 95. 1 person in 8 to 1 person in 20. Then you can be a attorney, a research analyst, an editor, an advertising manager, a chemist, an engineer, an executive manager, etc. Now, that's not the high end for IQ, by the way. You know, that it can go up. Well, it can go up indefinitely, although there's fewer and fewer people as it goes up. So if you want to be the best at what you're doing, bar none, then having an IQ of above 145 is a necessity, and maybe you're pushing 160 in some situations, and maybe that's making you 1 person in 10,000 or even 1 person in 100,000. And then also, to really be good at it, you probably have to be reasonably stress tolerant and also somewhat conscientious. So, you know, people, and you think, well, why is it that smart people are at the top of dominance hierarchies? And the answer to that, in part, is because they get there first, right? I mean, everything's a race, roughly speaking. And the faster you are, the more likely you are to be at the forefront of the pack. And intelligence, in large part, is speed. That's not all of it is. So if you're moving towards something difficult rapidly, the faster people are going to get there first. So IQ of 110 to 115. So that's 85th to 73rd to 85th percentile. Copywriter, accountant, manager, sales analyst, general manager, purchasing agent, registered nurse, sales account executive. If you look at universities, the smartest people they're above this. Who are the smartest people at university? What do you think? Mathematicians, physicists and mathematicians, right. I could tell you who's on the other end, but I won't. Yeah, I'd like to though. Anyways, okay. Going down now 103 to 108 is slightly above average, right? 60th to 70th percentile. Store manager, bookkeeper, credit clerk, lab tester, general sales, telephone sales, accounting clerk, computer operator, customer service rep, technician, clerk, typist. So you see at this level, people have some technical skill and some ability to deal with complex things. Okay, that's dead average. 100 is average. Dispatcher in a general office, police patrol officer, receptionist, cashier, general clerical, inside sales clerk, meter reader, printer, teller, data entry, electrical helper. 95th to 98. Machinist, food department manager, quality control checker, security guard, unskilled labor, maintenance, arc welder, die setter, mechanic. Good IQ range for relatively qualified tradespeople. 87 to 93. Messenger, factory production worker, assembler, food service worker, nurse's aide, warehouseman, custodian, janitor, material handler, packer. Now, what you're starting to see is that as you move down the hierarchy, the jobs get simpler, they're more likely to be assigned by other people, or they're repetitive. Because what IQ predicts to some degree is how rapidly you can learn something, but once you've learned it, it doesn't predict necessarily how well you do at it. And so the more repetitive jobs people with lower IQs are more suited to more repetitive jobs. Under 87, is there something? Well, no. Right. That's a big problem. And it's something our society has not addressed at all. Jobs for people with IQs of less than 85 are very, very rare. So what the hell are those people supposed to do? It's 15% of the population. What are they supposed to do? Well, we better figure it out, because one of the things that's happening too is that as the high IQ tech geeks get a hold of the world, the demand for cognitive power is increasing, not decreasing, right? You want to be a teller? Well, those checkout machines, they're not so simple. You want to work at McDonald's? You think that's a simple job? You don't see robots working at McDonald's. And the reason for that is that what McDonald's workers do is too complex for robots to do. So this is a discussion that no one wants to have, but that's okay. It's still a problem, and it has to be dealt with. So the US government, I think I told you this at one point already, it's illegal to induct anyone into the US Army if they have an IQ of less than 83, right? It's about 10% of the population. Because the US Army, and they've been doing IQ testing since IQ testing began, because they want everybody they can possibly get into the Army, because in peacetime, they use it as a way of moving people up the socioeconomic ladder, and in wartime, well, obviously, you need as many soldiers as you can get your hands on. And so you're not going to be any pickier than you have to be. So when the US Army says it's illegal to induct anybody into the armed forces if they have an IQ of less than 83, then you know that they've done it for absolute necessity. Right? And when people have made a finding that contradicts what they want to hear, and they're doing it out of absolute necessity, you can be reasonably true that it's one of those facts that just won't bloody well go away. And so you might think, well, if there's nothing for someone with an IQ of less than 83 to do in the Army, what makes you think that there's something that they can do in the general population? And then the issue is, because the conservatives will say, well, they should just work harder. It's like, sorry, that ain't going to fly. And the liberals will say, well, there's no difference between people anyhow, and you can just train people to do everything. And that's wrong. So they're both wrong, and they're seriously wrong. And the fact that neither side of the political perspective will take a good, cold, hard look at this problem means that we're going to increasingly have a structural problem in our societies, because we're complexifying everything so rapidly that you can't find employment unless you're intelligent. You guys are really going to face this, Lawyers are disappearing like mad. And the reason for that is, you can look it up online. Increasingly, you can do things yourself if you're smart. And so, the working class people have been wiped out pretty nicely over the last 30 years by automation and various other things. It's the low end of the white collar class that's coming up next. So I'm not saying that lawyers are in the low end, but low end lawyers are in the low end of the white collar class. So there's still going to be plenty of positions for people who are creative and fast on their feet and super smart. In fact, those people are going to have all the money, and that's already happening to a great degree. Because if you're smart and you can use a computer, you're so smart it's just absolutely unbelievable, right? And if you can't use a computer, and lots of people, and I don't mean, you can open Word. That isn't what I mean. I mean you can program, and if you can't program, well, you're right at the next end. So if you haven't got that with you, you're going to be left behind.
What's going to happen then when that happens, when you have...
Oh, a lot of them will take Demerol. That's what's happening in the United States. Yeah, it's an opiate. Yeah, so there's a massive drug problem emerging in...
Under 83 or whatever,
yeah.
it's about 15% of the population.
Yeah, no, I'm telling you, that is what's happening.
It seems like that percent of the population is going to increase.
Yes. Drugs. Yeah. Drugs of abuse.
The population falling out of society.
Well, what is happening to a large degree is people drop out of the employment race. They get very depressed. They develop chronic pain problems, especially if they're men, because chronic pain and depression are very much the same thing. And then they subsist on opiates, which are subsidized by Medicaid in the US. I'm not kidding about this. This is exactly what's happening. What else is going to happen to people for whom there's nothing to do? They have a terrible time, especially if they're conscientious. That's a good question. You know, the AI guys are pushing hard on this. Hey, what's the biggest employment category? Driver. Think about it. What's Tesla doing? What are all the AI guys working on as fast as they possibly can? Driverless cars. No problem, except that's the biggest employment category for men. So what are those guys going to do? Yeah, they're going to sit home and, you know, be miserable with their wives and take opiates because they have chronic pain problems. Right. Nasty. And you might think, well, could they think up something else to do? Well, if you have an IQ of 83 or less, you're not going to be doing a lot of thinking about something else to do. You know, that isn't how it works, because you're more of you're an act person, not a thinking person, roughly speaking. You know, and so if you have a task at hand, especially if you're conscientious, you can diligently go about it. But, you know, I've tried to train people with IQs of 80 and less to do what I would consider tasks that one of you could learn to do in 10 minutes and never make a mistake again. And it's like tens of hours with bare minimum mastery of the tasks. So, yeah, it's an ugly situation, no doubt about it. Okay, openness. So, creativity. Well, I can talk more about this on Thursday. Maybe we'll just stop and I'll go into creativity on Thursday. So we've got about 5 minutes. So if anyone has a question, I'd be more than happy to entertain a question. So what I tell you, like what you need, we're in a technical area to some degree, right? So you need to understand how these tests come about, because you can't understand the concepts without understanding it. So I'm hoping that the way I told you that the IQ tests were derived made sense. I mean, it's a fairly straightforward thing, but that's what you want to concentrate on. You had a question. Yeah, yeah. You can't train simple reaction time. It's really hard. You top out very rapidly. And but let's take your question a little further. So let's say IQ predicts how fast you'll master a video game. So then, and it does. So then let's say we're going to train the hell out of you on a video game so you get super good at it. And then you'll get like Tetris. You know, does everyone know what Tetris is? Okay, well Tetris is really an IQ test for all intents and purposes. It's a spatial rotation test. So you can get really good at Tetris, right? And you think, hey, my IQ's increasing. It's like, well, here's the problem. Let's say I produce a variant of Tetris that requires that the idea is basically the same, but it requires different operations. Being good at Tetris won't help you be good at that test. You don't get crossover. And people have been trying this for a long time. It's like, well, maybe you could practice a bunch of IQ tests and you'd get better. It's like, no, you get better on the IQ tests you practice, but you don't get better on IQ tests. And you see, even fluid, you can't move it. And there are people who come up with claims all the time, like the lumosity people. It's like, well, here's a bunch of complex. So then they thought, look, practice one test, that doesn't work to make you smarter. So then practice a whole bunch of tests, and then maybe what you'll learn across all the tests will make you smarter. No, it doesn't work. And it really sucks, because one of the things you'd hope is that once you had extracted out a central factor for intelligence, that you could get people to practice the micro skills that were associated with it, and it would boost IQ. It's like, it doesn't work. And you know, about every 5 years, someone comes out with a claim that says, hey, we've developed a new test, and if you just do this test, you'll get smarter. And then someone tests it out, and they usually use the Raven's progressive matrices as the marker, and they show, no, it's the same thing. Domain-specific knowledge doesn't generalize to other areas. So it's a hell of a thing. If you can figure out how to raise people's fluid IQ, you will be a billionaire. But you won't be able to do it because it looks like it's impossible. But you never know. You know, maybe someone will crack it at some point, but we certainly haven't yet. So, no transfer. No. There's no generalizability of a specific skill to IQ. So, you know, if you practice one thing and there's something that you're doing that's close to that, there's going to be some generalizability. It's kind of hard to define what close means, though.
In case of the Tetris example, let's say you change one factor, you add something new.
Well, it would depend on how big the factor you changed was, but the general rule of thumb is no transfer. Yes?
My impression is that, like, to generalize it, the person with the higher IQ would just be able to pick up on whatever factor you change and thus learn.
Oh yeah, the higher IQ. Oh yeah, the higher IQ person will learn the new thing faster, pretty much no matter what it is. Yes, yes. But even so, then you might think, well, what if you practice learning a bunch of new things fast? Would that make you faster at learning new things? And the answer is A, people are doing that all the time, so you're probably maxed out on that to some degree. And B, no, it won't. So, and believe me, people have tried this for a long time. So, and for good reason. And we haven't got anywhere. Yes? Yep.
People who don't learn languages have a hard time learning languages. So that's an example of
Yeah, the language one is tougher because, like, if you say you learn 2 languages, can you pick up the third faster? And well, the answer is it depends on how linguistically close the new language is to the 2 that you've already learned. And then if you learn 30, you can probably learn a new one in like 2 days. Because once you've learned 30, you've covered the domain of languages. So the language issue is a little bit more complex because languages have a fair bit of commonality in their underlying structure. So, but you don't learn one language faster after you've learned 3 because you've got smarter. You learn one language faster after you've learned 3 because you know more about languages. So, okay, we should stop. We'll see you Thursday.